Okay, so good day everyone, this is Crystal and here I am again with a new video tutorial. This time I'm going to teach you how to do a math word problem involving optimization. So if you're having this topic right now in school and you're completely struggling with how to do it, don't worry because I'm here and I'm going to teach you how to do it. Just stay tuned and don't forget to subscribe in my channel and press the bell button for you to stay updated with my new videos. So let's start!
So the problem goes, a rectangular cake dish is made by cutting out squares from the corners of a 25 cm by 40 cm rectangular tin plate and folding the metal to form the container. What is the size of the squares that must be cut out in order to produce the cake dish of a maximum volume?
Okay, so before we start solving the problem out, it's good to have a clear visualization first of how the problem looks like. So let's suppose that this is your rectangular tin plate measuring 40 cm by 25 cm and you are to cut out squares from each of its corners. Let's suppose that you've already taken out the squares. So this is how your rectangular tin plate would look like. And if you are going to fold these four sides up, this is probably how your cake dish would look like this. Okay, so let's set this aside for now and let's now focus on solving the real problem itself. So yeah, as you can see, I just tried to do some drawing of the tin plate and the cake dish because I know that some learners would learn faster if there are graphics and images. So I just want to make this tutorial as convenient and as easy to everyone as possible. Okay, so let us now try to analyze what the problem is asking for. So the problem is asking for the size of the square, the size of these squares that will be cut out from the rectangular tin plate first to produce the maximum volume of this cake dish. Okay, so since we don't know what's the size of each side of a square, we are going to use a variable. Any variable. So for now, let's use x. We will let x be the side of a square. Okay, so now we have x as the side of our square. So these sides will become x. So it means that whatever the side of these parts will also be the sides of all the squares. So now let's move on to getting the value of that x. So first thing we need to do is to make use of the formula in getting the volume of a rectangle since we are dealing with a rectangular cake dish. So the volume of a rectangle is equals to length times width and times height. Okay, so the problem now is what will be the length, what will be the width, and what will be the height. So for that, let's go back to this drawing. So as we know, the length of a rectangle will be deducted by the measurements of the two x's. Therefore, our new length is 40 minus 2x. And same goes for our width. 25 here will be deducted by the measurements of the two x's. So this will be 25 minus 2x. So now for the height of our rectangular cake dish, let's go back to this representation I showed you earlier, okay? So we all know that this side is x, this side is x, and all other sides of the squares. And if we're going to fold this thing up, we can then conclude that the x here will become the height of our rectangular cake dish. So easy as that, the height of our rectangular cake dish is equals to x. Now we can substitute these values to our formula. So it will become v of x is equals to 40 minus 2x times 25 minus 2x times x, wherein this is your length, this is your width, and this is your height. So this is now then the function for your optimization problem. Okay, so after that, let's just simplify this function by combining this with this and with this. So for that, you'll come up with v of x is equals to okay, so now as you can see, after combining your length, your width, and your height to each other, you now come up with the function of v of x is equals to 4x cubed minus 130x squared plus 1000x. Now, next thing you need to do is to have the derivative of this function. Okay, so if you're still confused and asking about how to get derivatives, well, don't worry because I already made a video tutorial about that, and I'll just leave the link in the comment section below this video. But for now, bear with me and you can just have that video later on if you want to know more about getting the derivatives. Okay, so now let's have the derivative of this function. So v prime is equals to so next is, now that you already have your derivative, you're going to equate this to 0. So, okay, so the next thing we need to do right now is to look for the critical values by looking for the factors of this equation. So as you can notice, it is a trinomial and it is in the second degree. So when it is in the second degree, we call it quadratic equation. So while there are people who can just easily get the factors of a trinomial by just looking at it, we can't deny the fact that there are also those people who would struggle and take much time to do it. So what I'm going to show it to you right now is a very easy, very convenient, and very quick method to get the factors of a quadratic equation. So this is by the help of what we call the quadratic formula. Okay, so I intentionally did it in two separate ways for it to be understood better and easier. So after substituting the coefficients of this equation to the variables here, you'll come up with the answer of 16.67 for the addition. Now, for the subtraction, you'll have the answer of 5. Now, the question is, now you have two values of x. Which one do you think would give us the maximum volume of our rectangular cake dish? Now we can't just guess for the answer between these two x's. There are actually ways on how to know which x would give us the maximum volume. That is, one way is to find for the maxima and the minimum. Now in doing that, you have to substitute these two x's into this function. And whichever x would give you the maximum volume or the maxima, that x is the answer. But do you know that there is actually a faster way to identify which of these two x's would give us the maximum volume of our cake dish? By that I mean we need to know the domain of our problem. By domain I mean we need to know the parameter of our x, like x should be greater than this but lesser than that. We need to know the limitations of our x. So in doing that, we need to base it on our values here. And I'm actually going to base it on 25 minus 2x. And later I'm going to explain to you why I chose that, okay? Okay, so if you're going to base it here, we know already that x should not be equal to 0. So x should be greater than 0. Now, why? We know that if it's 0, then 2 times 0 would be 0. 25 minus 0, it would be just 0, so you're not taking any square at all. Now, on the other hand, x should also be lesser than 12.5. Now, why? Because we know that when we substitute 12.5 here, we will have 2 times 12.5 would be 25. So 25 minus 25 is 0, which means you'll have no more cardboard at all. Yeah, so that's why our x should be ranging from 1 to 12.4, at least like that. Okay, so this time I'm going to explain to you why I did not use 40 minus 2x but instead 25 minus 2x. Well, it is because we know that if we're going to base it here, we can have a domain of x is greater than 0 but lesser than 20. So that means our x can range from 1 to 19. So that means that if we can have 19 here, 40 minus 38, you'll still have an answer of 2. But then if you'll have 19 and you're going to substitute it here, you'll have 25 minus 38, which is a big no-no because you'll have a negative answer to that, and there's no such thing as negative length, right? Yeah, so that's why I used 25 minus 2x. So I hope you understand that, and if you still have much more question about that, don't hesitate to leave it in the comments section below. Okay, so now that we already have our domain, we can now check which of these two x's would fit in our criteria or in our domain. So, 16.67 clearly exceeds our limit, which is 12.5, right? How about this 5? Yes, it does. Because we know that our x can range from 0.1 to 12.4. And 5, it clearly fits. So that means that 5 is actually the value of our x that would give us the maximum volume of our cake dish. Okay, so we can actually check for it if 5 is really the answer and if 5 would really give us the maximum volume of our cake dish. So we can use finding minima and maxima to check that. So like what I've said earlier, we can substitute the two of them to this function, and let's see if 5 would really give us the maximum volume. So yeah, let's do it. Okay, so as I substitute 16.67 to this function, it gives us an answer of negative 925.93. So, well, if you're going to substitute 5 to this function, you'll have the answer of 2,250. And it is very clear that 2,250 is much bigger than negative 925.93. So that means that, yes, we're correct that 5 is the size of the side of our square. Okay, so there we already have it. We can now answer our problem, which is asking for the size of a square that should be cut out for us to produce the maximum volume of our cake dish. So yes, the answer is, it is a square having the dimensions of 5 cm by 5 cm, which is going to give us the maximum volume of 2,250 cubic centimeter. We were able to answer it, and it's so satisfying. So thank you so much for staying up with me and watching my videos. Okay, so should you have more questions and clarifications about this topic or this problem, please don't hesitate to leave your comments in the comment section below because I would always love to read it. So again, this is Crystal and telling you to study well because the world needs you. Yeah, so that's it. Thank you so much and have a good day.